Okay, so let's go through the setup for the thing, the auto sort of visualizer kind of deal. And so essentially it's in two parts really. This particular one is the blueprint. So essentially it's a blueprint, an empty blueprint actor that we've added some components to. Sorry, there's somebody getting in and out of a car outside. And this is the blueprint that's going to control the sort of generation. So essentially it's going to regenerate through the PCG graph. And you'll see that there's a PCG component here. So we've added a PCG component with here, and then just type in PCG. So you can just add a PCG component here. I started off actually with this inside a box and just generating a landscape, but I actually kind of prefer it along a spline because you can set the points along the spline, so it looks more like a sort of audio visualizer. So again, just go to add and then spline component. So this one at the bottom here. And then you can edit the spline. Sorry, and then you can edit the spline, you know, like you would sort of any other Unreal Engine splines. If you look for a tutorial on editing splines in Unreal Engine, you'll probably find them. So next part is we add some variables, and the thing that's really important here is this get magnitude for frequencies. So essentially what that does is it takes in an array of floats. So you can see, because it's got these like square boxes in, that this is an array, and because it's green, it's a floating point number. So it takes an array of floats, and for each float, that represents the number in that float should represent the frequency domain that you want to get the magnitude of. And the magnitudes come out, if you read the documentation for this node online, the magnitudes come out between 0 and 1. I think it's 0 and 1 or minus 1 and 1. I think it's 0 and 1. For that particular frequency. So essentially what we can do is we can say, get me the magnitudes for whatever's currently playing in the sound sort of mix, and, you know, grab that floating point value. So just to sort of take you through the setup, in begin play, I've created this frequencies array. So if we want to create a new array here, we drop down to here and call it float, and then right click this to turn it into an array. That's something new in like recent Unreal Engines. So again, you know, you can create new variables as much as you want, but we'll just delete that one for now. So I've created a couple of arrays. So some of them are kind of like temporary arrays that we're going to recalculate, but other ones are ones where we want to store the values. So in this particular case, the number of frequencies that we're going to store, I've made an integer variable called num frequencies. And what I'm going to do is I'm going to calculate the frequencies that I want to capture. And the reason why I put this as a variable is because then I can change how many steps the frequencies are. So, you know, I can basically say how many bars I have in my visualizer. So then I go through, after I've cleared the array, so essentially now the array would be empty, I then step through this for loop. So again, you know, you drag off here and create for loop, and there's a few different types of for loops, so you might have to try out different ones. But what I'm going to do is I'm going to say between 1 and whatever number of frequencies I've got, so 128, 256 or whatever, I'm going to take the step size, I'm going to multiply whatever index it is. So in the for loop, it obviously iterates from like 1 to whatever the maximum number is. So this is the maximum number. And it says multiply that with my frequency step size. So my frequency step size currently, if I just show it over here, is set to 100. So essentially I've got like frequency bins of 100 like hertz, I think it is, in size. And I'm adding that value into my frequencies array. So remember, my array was empty, and the for loop is essentially filling it with frequencies that are 100 hertz in size, like in terms of like distance between each other. And so once that array for loop is completed, now I've got a frequencies array that's got number of frequencies or values in it. And I can call this get magnitude for frequencies. And what that does is it grabs whatever the sort of main master submix is if you don't give it a value. So you can actually ask it which submix to grab hold of. You know, if you've got like lots and lots of different mixes going on at the same time. But currently I just want it to grab whatever's playing currently as the sort of main mix. And it grabs that into this array here. And this is just their name for the output, right? So we actually do store this. And what we're doing is we're storing the output of that array. So essentially the number of frequencies will be output in this array. And I'm storing it in this normalized audio values. So essentially the normalized audio values are like that 0 to 1 range magnitude of whatever the current sound is playing. And then this particular node, I was just testing something out. I don't think it has any impact. I was just wondering if it could use it for analyzing FFTs and stuff. But in this case, like, you could ignore that one. And then for testing purposes, I just added a play sound 2D and chose a particular, like, I've got in this variable here, I've just got a sound clip that we can play. So thinking about it, I should probably just disconnect that one because we're going to play it in. Well, yeah, okay, you can play it wherever you like. So that just starts sound going, right? And so the main part of this is in the event tick. And so what we're going to do in the event tick is we're going to clear our magnitudes floating point array. We're going to clear our normalized audio floating point array. So basically those will be empty at the start of each tick. We call that get magnitudes for frequencies thing. We didn't actually need to do it at the begin play, thinking about it. We could have just ignored that one, but I wanted to test it out. So when I was debugging it, I probably left that in. So we're going to call that function again, get magnitude for frequencies. We're going to store the value, the output values in both magnitudes and normalized audio values even. And the reason why I'm doing that is because I want to basically mess with that array for the visualization output. And so the next part I've got is this Boolean value, which is an option for me to be able to. So currently I've got like all of the frequencies I've asked for, and I've got all the magnitudes for those frequencies. But what I found was that when I was like visualizing them in the PCG graph, ultimately it looked a bit lopsided because all of the high values were in like the lower frequency domain. So essentially I had like a big sort of lump of values in one place and then nothing to the left of it and hardly anything to the right. So I decided what I was going to do is I was going to take those magnitude values and I was going to reverse them and add them, or append them in this case, to our normalized audio values. So essentially what that's doing is it's saying, take what I've got as a buffer of magnitudes, add it to itself, but reversed. So you get this kind of like copying value. And then all I'm doing is saying however many values that results in, make sure that that's set in our num frequencies, because that's going to be used in the PCG graph. And so the final part, and this is an important thing to sort of realize, is that we call generate local on our component, on our PCG component. So essentially we're feeding the PCG component, and this is important. You need to set the force Boolean to on. So basically it says regenerate now. So every event tick in our blueprint, we're telling the procedural content graph to regenerate its contents. Now, it's not massively, it's quite a heavy burden on the regeneration. And it might be that if you've got a slow machine, it would fail and those kind of things. And I did try telling it to notify when properties change so the blueprint could update and things like that. But in the end, that didn't seem to do the same thing, or at least didn't seem to do what I wanted. And I haven't figured it out for the rest of it yet. So essentially, all that's doing is it's getting the frequencies with this function, get magnitude for frequencies. it's doing a little bit of monkeying around to make it visually prettier, and then it's calling regenerate on the procedural content graph. So the procedural content graph's the bit that's kind of more important here. And so if we actually go to that graph, obviously I've tested a load of stuff here as well. You can kind of ignore these ones because they're all switched off. But what's actually happening is that in our PCG graph, you'll see there's a bunch of errors, and that's because okay, that's interesting. The errors are there because when it's querying the variables to use, it actually gets essentially nothing until it's running live. It's quite weird, really. So what we're going to do is we're going to get the spline data. So the spline data is the thing that's going to like show us where to draw, right? So we've sampled like landscapes and stuff, and I've done that up here somewhere, like a landscape data. So you can use get landscape data for sampling on a landscape. We could create a point grid if we wanted to and do that slightly differently. But in this particular case, in this PCG graph, we've got a spline on our self, right? So essentially we've set this actor filter to self. So essentially in our PCG graph, we've got a spline component. So we can get that spline component from ourself as an actor. And then the next part we're going to do is we're going to query something from our blueprint. So essentially the PCG graph is running inside the blueprint. So it can query itself as an actor. And so in this particular case, this get actor property is getting this variable called num frequencies out of the actor that owns it. So essentially it's getting this num frequencies integer value. And the reason why that's useful is because in the spline sampler, there's actually this num samples value. So essentially we're overriding how many points we should get from our spline, how many points we should get along our spline, sorry. So we're reading properties from actors and using that in our generation setup, which is kind of the main point of this. And so the next part is that we're going to get the actor data. Let's just move that down for now. We're going to get the actor property, but in this time, we're going to get normalized audio values. So when you're entering these get actor properties, you have to give it the name of a publicly facing. So like they have to be public, the icon here has to have the eye icon. And in this particular case, normalized audio values is a floating, array of floats. So what's essentially happening here is that this get actor property is asking for an array of floats. And so what we're doing with this particular node is just adding some values together. And in this particular case, we're doing the add operation. So it's an attribute maths operation. And it's saying, take the current value of whatever's in scale and add some, whatever the input source of this is. And in this particular case, I've called that value the output attribute name. So this is the input name from our get actor, and that's the output name we're going to give it. So I've called it test because I was trying to figure out why it wasn't working, and I'd obviously used the wrong name. So I've said, right, okay, so the input source, we're going to get property test, and we're going to multiply it. So, we're going to add it to our current scale. So essentially, we're going to take our current scale and add some value to it. And then we're going to spawn a static mesh. And this could be any static mesh, right? I've created like a sort of slightly glowy cylinder. Where did I put that? Might be in meshes. Nope. Might be in audio. Nope. This is why it should be a bit more. Oh, it could be in PCG. No. Anyway, take my word for it. I'll put it somewhere. Could it be in materials? Oh, yeah. For some reason, I created it by using the modeling mode in Unreal Engine, just because it's, you know, it's literally just a cylinder. It's actually a very small cylinder. And obviously we're scaling up, right? So essentially what I've done is I've created an emissive material and applied that to the cylinder. So creating materials and creating simple models and stuff shouldn't be beyond the sort of creative person, I suppose. And then we're just spawning that static mesh. So essentially every update, every tick in this blueprint is calling this generate local on our PCG component, which is set to our PCG test graph. And all our PCG test graph is doing is sampling some data from the spline to say where this thing should spawn, and then taking those points and adding some values to the scale for those magnitudes, those number of frequencies, remember. And then it's spawning the static mesh with that scale value. So essentially this add value is modifying the scale value that then gets used in the static mesh spawner. And then that gets applied to the output. So in essence, the thing that I think is the real takeaway from this is that you can sample from, like in your PCG graphs, you can grab data from other objects. You can capture it from literally any actor in the world. You don't have to use self. Self just means like it's on me, it's on my sort of parent actor, right? So if I'm a child component, it's on my parent. But actually you can query, you know, all of the actors in the world. You can, you know, you can do things like test for specific tags and that kind of thing. So you can actually, you know, look for a particular data actor. Say maybe you have an actor that's got like all of your data values in it, and you can use that to drive your different PCG graphs. Because if you think about it, your data could reside on lots of different sort of places, or it can all be in some central repository with maybe a user interface, and it can read from that same central repository all of the data they need. So you could like orchestrate a bunch of different PCG graphs and maybe cause them to regenerate themselves. So definitely try out this concept of like get actor properties and just play around with it, right? Make one value. I mean, I've made a bunch of arrays and stuff, but just make one value and see if you can read it, because that's a valuable technique, I think, that's worth doing for PCG. So there you go. We'll go over this again when I think of a little bit more interesting sort of, you know, feature set for it. I kind of want to do spaceships shooting at each other or something, but I'll have to think about how that will work. So there you go.